Hi, everybody. Thanks for joining. And what I want to talk through today is it's really an amalgamation of the experiences we've had and the best practice we've learned over more than a decade of helping people digitize automotive plants. So I'll be talking to some of the best practices that we've seen other people execute successfully that you can hopefully emulate and learn from. And I'll also talk a little bit about some of the ways that you can fail at this, which is really the flip side of the coin. So I want to start very quickly. I'm not really here to talk about us, but why the heck should you listen to what I have to say? So UVisense is a company that's deeply embedded in process digitization. We do that across a lot of industries. Our primary focus is discrete manufacturing. Within that, our biggest market certainly is automotive. And what we do is we're in the business of digitizing manual process, that complex interaction of all the critical assets and tooling and products that make up a complex moving process. And we help people improve productivity, quality, and safety. And we've been doing that for a while, right? So if we have a look at a timeline here of this kind of digitization industry, if you wind back to about 2013, that was when the Industry 4.0 report was published in Germany. That was kind of the start of Industry 4.0, and when we all started talking about things like cyber physical systems. And before then, back in 2011, was the first time that the Internet of Things appeared on Gartner's emerging technology hype cycle. Emerging technology that would plateau 10 years or more in the future. And back even further, back in 2008, really kind of the birth of IoT proper was when the IP for Smart Objects Alliance was founded. And that was the year that we were doing our first mission critical process digitization projects. So I always kind of half joke that we've been digitizing processes since before process digitization was a thing. So we've been doing this for a while, and that was based on research that our founders were doing in the 90s about digitizing space, and the company was founded in 2002 to commercialize what became known as location intelligence. So I lay this out just to say to you, we've been doing this for a long time, so we've accumulated a lot of years of knowledge and best practice, and I want to share a little bit of that with you. So in a nutshell, just to get us started, what are the kind of banner headlines of what we've learned? And I'll go into each of these in more detail as we go forwards. But the first thing is you can make a very modest start to digitization. It doesn't have to be a wholesale enterprise transformation like from the start. That's a good way to get bogged down in kind of analysis paralysis. So I'll talk about modest starts. And the other thing I'm going to talk about here is what we've seen work well for people is taking a very cautious incremental approach. I always say, why transform in 3 steps when you can transform in 103? So I'll talk through where we've seen people make progress along an incremental path. And you don't have to wait years back. There's certainly, in some places, a perception that large-scale transformation is a thing that pays back over a long period of time. It's a huge change. It's a huge investment. There are rich dividends, but it takes time to get those. And I'll talk through why I think taking this stepwise approach is a way to get payback very quickly, and to keep getting more payback at each step. You do have to start right, and I'll talk about this some more. You will make technology choices early on that will determine how far you can go before you hit a brick wall, before you find the edges of technology choices. So that's an important part of getting started, sure. And then you do kind of have to step outside the OT box. This is IT now. There's a lot of discussion about OT-IT convergence in the industry, and it's not for nothing. digitization truly is bringing IT all the way out to the edge, all the way out to the shop floor in a very odd operational way. And that has implications in terms of purchasing strategies, and it has implications in terms of how you evaluate return on investment as well. And we'll get to that right towards the end. So let's look at getting started then. What are necessary ingredients to get started in what is probably going to be a many-year implementation path for digital strategy? So what do you need to get started? Lots of things, but these three things in particular. Like, number one, a pressing operational issue. Number two, a corporate will to improve by investing in change, very important. Number three, champion, not just willing to innovate, but build internal partnerships. and I'll talk through each of these here. But building those partnerships is important. What you don't need a greenfield site. You don't need $1 billion budget. You don't need a detailed master plan. All those three things are, when we find people taking that approach, that's a recipe for never quite getting started, actually, because you create such a high barrier for yourself that it's hard to even take the first step. So pressing operational issue, this probably is obvious, I hope so, but anybody we've worked with who is implementing a digital strategy for the sake of the digital strategy, because other people are doing it and they've been persuaded that they have to do it too, that is not a recipe for success. These transformations have to be done around real operational issues, and in the initial stages, pressing operational issues that need to be solved, and that's critical. These strategies to get born and get started have to coalesce around something that is clear and tangible and tactical. I'll talk about that some more, but a tactical problem-solving step, right? So that's number one. The second one, a will to improve by investing in change. I'll come back to this when I talk about good ways to fail, but the point of transformation is to create opportunities to do things in new ways. That's a double-edged sword, and I'll talk about that balance in the next couple of slides. On the one hand, if you're not willing to change, nothing's going to change. Right? That digitization won't change anything unless you leverage the freedoms it gives you to do things in new ways. On the other hand, if the technologies you ingest force change upon you, that can be a very high impedance way to bring digitization into an operation. What you want to be able to do is make changes in incremental steps, manageable steps. So every new initiative needs an internal champion, and those people tend to be the innovators, but they also need to be the coalition builders as well. The OT-IT convergence piece is not to be minimized. Culturally, procedurally, organizationally, companies create and have for a long time had barriers in place, and digitization is something that transcends those barriers and creates a need for people to work together across those silos. And you always have to cross those barriers. It always has to be done. It can happen the slow way, but the fast way, and honestly, we've seen people go probably 3 to 4 times faster in their initial stages, is if you have that great champion who has the visibility and connections internally to build these coalitions and cross those barriers. That's a really key point. And I think out of those three, the people we've seen have the biggest early on success are the people that have had that person in the loop from the start. So you don't need a greenfield site. You don't need to wait till you're refurbishing a plant or building a new plant. to build digitization in from the foundations up. Digitization can be, and very often is, an overlay technology. It's something you can do while in production. In fact, there's a lot of advantages to doing it while in production. So you can start at any time in any place. Right? It's not predicated on a place where you could build it in right into the foundations. To get started, you don't need $1 billion budget. You may spend $1 billion over the next decade, but in step one can and should actually be really quite modest. There's a lot to do in the first step or two to get set up for a roadmap of adoption going forward, and so you do actually need to keep those projects small. And some examples of that here, and which is kind of the same thing as saying you don't need a detailed master plan. Another way we've seen people really slow down their initial steps is to spend a good deal of time trying to think forward to some future state and create a very thorough, well thought through view of what that future state is. And I think that's not necessary. If you can do that, then great. There's a big but there, which I'll come to. But most people can't, and nobody needs to. And I'll explain that here as we look at this kind of thing, right? So how do you not get bogged down in that end goal definition? Well, if you take the advice, which is to take the first step around a pressing operational problem, then it's pretty easy to define the problem that you're trying to solve and the desired outcome in that single step. And that might be very small. The smallest start point that we've seen was around creating a digital workspace around a single tool in one workstation on an assembly line. From a global manufacturer with plants all over the world, right? So the smallest possible unit of digitization they could have made was around a single process, and that's what they did. And it made it very straightforward to define. Very clear what the problem was, very clear what the outcome should be, very clear what the solution should be, and something that's really quite straightforward to execute from a technical standpoint. So, step two gets a lot clearer once you finish step one. You might already be saying, look, okay, that process there, if we can fix that, we can probably apply that same technology to this process over here, and that one over here, and that one over here. And by the time you've finished step one, you'll have learned a great deal that allows you to define step two in perfect detail as well. What's not so clear are the steps further out, but it's okay. Those are further out in time. You will be a different organization by the time you get there. You will be a lot smarter, and that step will come into focus as it comes at you through time. And this future state, this kind of end point, which by the way never ends, you'll never be done transforming. I mean, that's obvious, right? But that's part of why there's really no point in trying to define this fixed future vision in very specific terms, because it'll change over time. Not only will you learn more and more as you go through these steps, which will make you better at trying to define that future vision, but your company will change, your strategy will change, the market will change, the world will change. So trying to peg that thing down now is almost an exercise in futility. So the first in the initial stages is around tactical problem solving. And that's something we can all get our heads around. It's something that we do every day. And as I said, those people that take that approach in the first few steps get going very quickly and see success very fast. The future state is all about a vision of some strategic outcome. We want to create digital visibility from end to end across our supply chain, so that we can make optimizations in real time based on the entire process. Okay, that's a vision. Great. And that's what we should head towards. but it doesn't need to be defined in terribly much more detail than that. So what happens then is, as time goes on, finish step one and step two comes to be the next step, and step three, and on the right, your future state is going through kind of versions, because every time you move forward in this process, you're refining and extending what that future state should be. But always, step you're on is pretty easy to define, because it's the problem right in front of you that you have to solve next. So let me give you an example of what a stepwise approach looks like. And some of you, if you joined my previous webinar, will have seen this slide. And I bring it back here because I want to remind you of it, but I also want you to think about it in a different context. And that is the context of, how do I put together a program of digitization that focuses on individual problems? So what I've got across the top here are the very analog parts of a typical automotive assembly process, from inbound logistics through assembly through distribution. And these are the traditionally not particularly digital at all parts of a process. And so let me step you through what a typical step-by-step tactical problem-solving roadmap might look like. And it might start, for example, as I said, the one great example I said to you was a tool control example where we had a company that wanted to create a virtual workstation around a single tool. And that can be a very modest deployment that might extend and then into digital process triggers across the assembly line. Lots of process need triggering, not just on but off the assembly line. Doing that digitally in software is quick to add triggers, quick to modify them, and is a very convenient way to get rid of a lot of mechanical analog plant out of the process. That might extend then into flexible workstation. Once a workstation is defined as software, they become flexible and give you now, the first two steps are really very specific problem solving steps, but now we're talking about what can we do that's new and different, new ways of working. Maybe workstations that change size depending on the model. The 4-door side curtain airbag workstation's a bit longer than the 2-door side curtain airbag workstation because the side curtain airbag has 2 apartments, as an example. So moving on from there, then, if workstations are flexible, they don't need to be stationary anymore. They're defined in software. You can do whatever you like with them in real time. And maybe now we move workstations along assembly lines and throughout assembly processes that give you full quality control and error proofing if you're doing rework activity online. And then you might move into the nonlinear parts of a plant, and depending on the kind of manufacturing, you may have a good deal of nonlinear assembly content, or in the high volume case of a passenger vehicle, what we're looking at here is more like the the repair and rework department. But in many situations, there's a fairly non-linear process that's quite complex to manage. It's usually quite ad hoc to manage as well. And so you may start with process monitoring just to give visibility of the flow of process over time and identify issues and bottlenecks, which allows you then to do some optimization, maybe even redesign of the facility if need be, to more real-time aspects of optimization, like having sufficient detailed view of the disposition of your products and the disposition of your resources, and being able to make much better decisions about what is the optimum next step to maximize throughput, for example, down to even automating that. So a digital brain in the background is constantly assessing the changing circumstances and telling you how to be optimum. I'll go through these quickly. Outside yard, you might start with whip tracking because you spend a lot of time finding things, through to monitoring for things that have been left in the corner. That tractor that got parked out on the back 40 and hasn't been brought back in to get finished off for the last 3 weeks, all the way to kind of integrating that in with the next step decision making. And then back through logistics, automated Kanban. It might be a digital project that you execute. Delivery monitoring, whatever my delivery method is, be it tugger or forklift or AGV, am I optimizing the routing? Am I error-proofing those deliveries as well? Are they going to the right place? Being flexible in real time so that you can optimize routing, so that you can optimize buffer sizes of parts on the line side as well. Right, and I'm going to go through these through warehouse management, FIFO enforcement to stop aging materials, error-proofing loads, making sure people are picking the right thing, routing optimization to get the loads pushed out in the most optimal way. Same thing out on the inbound side for trucks and trailer tracking and error-proofing the loads and dock door management, and even on the outbound side as well, right? I mean, there's load error-proofing and optimization and triggering carriers to come pick up loads when they're complete. And I could go on and on and on, but what I wanted to build a picture of here is any one of these things could be a start point, and 100 more that I haven't even thought about. But the point about the way I've written these things is each of them is a specific project. Each of them solves a specific issue that's probably fairly well defined. And these are the kinds of things that I'm talking about. When I'm talking about taking a stepwise approach, I'm talking about packaging things up in chunks that are about this size, right? You know, maybe we want to go to a digital warehouse, okay? And what we want to start is something really simple. Step one, we're just going to track parts so we know where they are. And then we're going to use that to make sure that parts don't get shoved to the back of a shelf and start aging on the shelf. So we're going to enforce FIFOs when people pick loads up. And then we're going to do error proofing to make sure the loads have been picked up right. Maybe a kitting activity to make sure a load has been assembled with the right parts in it. And so on and so forth. Right? So you can see how these incremental approaches can take place, and they can start anywhere in the organization. So that's what I'm talking about in terms of a stepwise approach. And the key thing about this that I want to come to is this here, which is digital factory as an outcome. So if you can go through these steps, and you can do that in a stepwise manner, and you can do them in a coherent and connected manner, so that each step builds on the ones before, then you can spend the next several years in a fairly tactical problem-solving mode, which is the normal mode that most people are in. Finding issues, deploying solutions, improving outcomes, right? Step by step. When you've done a bunch of that across the enterprise, you can turn around and look behind you and say, well, darn it, if I didn't digitize the entire thing, right? So when I talk about digital factory as an outcome, I mean that this is the don't get stuck on this giant future state as your initial planning process. You'll get there, and in fact, you'll get there by a series of problem-solving steps. Digitization across the enterprise will come as a result. It kind of emerges. So those steps are a way to plan, but they're also a really important way of managing risk as well. One of the things that causes people to either fail or slow down is literally just biting off a project that's just too big to swallow, right? Trying to do too much in one go. On that previous chart, if I go back up, imagine if you tried to do all that at the same time. Imagine if you had to sit down and write a spec for a solution that did all those things for you. Very, very difficult to do, and it would be fraught with risk and execution as well. Whereas any individual piece of that is executable and much lower risk. So the stepwise approach reduces risk, and it creates this virtuous cycle, because every time, and this is what I was talking about, you'll grow and you'll get better. Every time you complete a step, you've acquired new skills, and you will be acquiring new skills. A lot of this is fairly new way of thinking and a new way of doing business and new technologies, and skills will need to be acquired. You'll have to, work out those transformation muscles. But you do that gradually, step by step. Every step you complete, you get smarter. Every step you complete is another proof point. Every step you complete, if you do it right, provides a financial return. And every step you complete builds up and builds up and builds up internal support for what's happening. The evidence that this is a good thing to do just builds to the point where it's just obvious to take the next step. You know, the first few steps, there'll be a lot of conference room time, wringing hands, thinking about, should we be doing this? 5 or 6 steps in, nobody's asking those questions anymore because you've built up these proof points and that internal support. So what I talk about is emergent transformation, right? The transformation is an outcome. Transformation kind of emerges from the activity. So, you know, if every time I finish a step, I complete step 1 here, now I'm in my planning phase on step 2. As I said previously, you've got the skills and proof points and return and the support that you've created in step 1, and all of that is currency that you're going to bring forward into step 2. And step 2 is going to be a little bit easier than step 1 was. But additionally, step 2 feeds additional value back as well. So let's take the warehouse management case that we just talked about as a very simple example. Let's say step 1 was, where are my parts? So that has a certain level of value, right? What kind of return is that going to give you? It's probably going to reduce some search time, and that may be it. That may be a return, not huge, but good. And let's say step 2 where you went into load verification, where you said, okay, here's a forklift picking up a pallet, and I know exactly the nature of that pallet because I know where everything is, and I can verify whether this guy's picked up the right pallet. Well, that might be a much more valuable step because what you're heading off there is the wrong thing being delivered and being discovered at the point of consumption, right? Which can be quite complicated to untangle and more costly. But what you've done is you've added more value to knowing the location of the parts in step 1, right? Step 1 was just contributing to lowering search time. In step 2, step 1 is now contributing to decreasing error rates. So what I mean by step 2 feeding value back is that step 1 has X value, but when you do step 2, step 1 may have 1.5x value, and so it goes forward. And so you end up with this virtuous cycle where each step gets you smarter in terms of execution because of the things you've learned before, and each step kind of feeds back through the chain additional value, and life gets better and better. So that's what I mean about emergent transformation. This kind of ever-increasing value of connected digital process, right? So connected, not meaning connected in the sense of like, you know, IoT creates connected devices. What does that mean? Devices connected to the internet. No, what I mean is individual solutions to tactical problems that are solved with the same set of tools. They're connected because they're all part of the same solution, effectively. I use the tools to solve step 1, and I use the tools to solve step 2, and connected in that way. And what that means is, once you've got step 2 done, you can think of this integrated, you know, digitized step 1 and 2, and as you finish step 3, integrated, digitized steps 1, 2, and 3, right? And as you go forward, if you do it right, that builds and builds. And what it means is that the digital processing power that you can throw at optimization, error proofing, and throughput and safety and quality and all those things has more and more and more information to work with, and it's all connected together. So that's what I mean by emergent transformation. So, for example, right, if you let's say the orange ones on here, you'd executed those, and parts tracking allowed you to save some search time in the warehouse. Optimizing the delivery routing for shop floor logistics allowed you to get parts to the line quicker, right? Flexible workstations allowed you to create virtual workstations that create error-proofing bubbles that travel with the product down the line. and that enables you to do online rework. But if you connect them all together, then you can do things like, as soon as parts get delivered into the warehouse, now we can factor into the process and figure out where the best point is on the line to create a digital overlay rework station. We can task technicians to get there at that particular time. We can give them all the wireless tooling they need because we control that digitally, and we can do all the error proofing and work instruction that's needed to get that done. So connecting those together has created a new way of doing online rework that we wouldn't have had if we hadn't have connected them. And that's one of a bazillion examples of where you get like this holistic value by completing multiple steps. So let's talk about technology choices. And I alluded to this and said, some of the early decisions are going to be around technology, and one of the key things you want to do is avoid a dead end. Meaning that one of the hardest things you're going to have to do actually right in the early phases is making some fundamental technology choices that have legs, right? That allow you to go as many steps in the future as you can, hopefully all the way forward. But certainly technology choices that kind of peter out in terms of capability after 2 or 3 steps are to be avoided for obvious reasons. And there are 3 kinds of foundational investment that you'll need to make. I mean, any digitization project needs these things. First of all, sensors. That there is no digitization without sensors. These are the things that take analog process, which manufacturing is fully analog. We build analog things in an analog world, and they create digital data about those processes, right? So there are all kinds of sensors, but without those, you've got nothing. Networking and computing. I mean, the sensors need to be connected, so they need to have data connectivity. And you need compute resources because you need to be able to process that data. And there's some kind of software you need to do something useful. There's some kind of application or solution level software that actually takes that data and does something that creates business value. So to my mind, this is the hardest part, truthfully. It's really important early on to get smart enough on the technology choices that you can really make proper comparisons between options. And it's not a straightforward thing to do because, just looking out there into the world and listening to the sales guy and reading the marketing material, it's really quite hard to fathom what's different between one solution and another. And I'll give you an example from my kind of experience of the world. And as I said at the start, we're kind of involved in this digitizing manual process with a lot of moving parts, and the critical sensor there is a location sensor. So where are the tools, where are the products, where are the parts, et cetera, et cetera. And a location sensor that tracks where a vehicle is out in a yard outside is totally different from the technology that's going to allow you the millimeter accuracy to say whether I'm fastening the right bolt with my torque tool. Right. So what we see is that there's kind of a very limited understanding of how to differentiate between those sensor types, and therefore we see a lot of RFPs that ask questions that aren't going to give you any data to make a choice. Right. So getting smart about the sensor technologies is really key. Doing the due diligence, learning, getting into the technical of it. And that's why, having this champion that is an innovator, it's obviously a technical person. That person or that person's team needs to have the skills to drill into these technologies and understand what the differences are. So absolutely make sure that you understand what you're asking for so that you can make better choices. Networking and computing sounds a lot like IT because it is IT. Right? As I said, lots of conversation about OT-IT convergence. And if anything is true, factory digitization, industrial Internet of Things, Industry 4.0, whatever you want to call it, it means the IT-ification of controls, right? It means IT reaching right out to the edge and right into the real-time processes on the shop floor. And so it's time to break down that barrier, and it is a barrier. It may not be for you, and in which case you're ahead of the game, honestly. But for many, there's quite a gap between IT and OT, as I said, not just organizationally, but culturally as well. It's important to bridge that gap, and part of bridging that gap is also having a sensible conversation about the cloud. It really is a game changer. The cloud is a lot of things. Importantly, it's probably better service than you have, better managed with better security, and all those things might sound completely wrong to you, what I just said. But that's what's emerging as the truth. I was interested to see, I think this was last year, if you guys remember, the credit agency in the US, Experian, had a big data breach a couple of years ago. And last year, the new CEO, the old one didn't make it, the new CEO was explaining all the things that Experian were doing to improve security. And one of the things, the banner headlines was, we're moving all our operations to the cloud. So, it's time to get serious about thinking about that, because it is a really straightforward way to add compute on a on-demand basis. And it really fits nicely in this world of digitization and sensorization. And I'll come back to the cloud here in a little bit as well, when I talk about purchasing options. And then the last piece is software. I mean, none of that's very useful unless you have a software that does something, right? So here the important thing is to take a platform approach. What you're looking for is software that can grow with you. If you imagine a software application, right, that can go down that path that we looked at with all those steps, all those technical steps. But you don't need a warehouse management solution. Don't need an assembly control solution. But you need a platform that can be configured into delivering the application level behavior that you need. Right? So in terms of the software, it's not vertical software anymore. It's very horizontal approach, and you're looking for there is capability and flexibility. That means you can instantiate really any kind of application behavior that you need to. And that's the approach we take, for example, with our platform as a location intelligence platform, and it's very horizontal, but it does have tools that allows people to configure the behavior that they need, and that's really important. The other thing that's important here is that this is not a make versus buy thing. That ship has sailed. This is a buy. You're not going to make the kinds of platforms that you need to take you into the future with digital transformation. It's not in the skill set of most of the actual end users in any vertical industry. It's a particular skill set all by itself. That there is a kind of a make tendency built into everybody's DNA, I think. People always ask us, what's the most common MES you integrate with? And we always say, well, it's a different MES everywhere we go, because everybody has made their own. And those days are kind of past, I think, in these transformation platforms. What you do want to make is your application behavior. You don't want to create Microsoft Excel, but you do want to write your own spreadsheets. It's Excel that you're buying, and it's spreadsheet that you're making. And that's why I'm talking about a platform. Write a platform, make the applications you need to on top of the platform. Scratch the make itch, but don't be tempted to try to recreate the platforms. It's a complicated business. And the thing is, right, and why I talk about that long-term aspiration, nothing I've said really needs that in place, except you kind of need to know where you're going. Right? If your long-term aspiration is, we're going to create a digital logistics process, that's one thing. If your long-term aspiration is, we want to digitize across all our operations, that's an entirely different thing. And I talk about getting on the right mountain. If you have a goal of climbing to 10,000 feet, there is absolutely no point starting up a 5,000-foot mountain. And the first couple of thousand feet of those mountains probably look exactly the same. And this is what I'm talking about in terms of making the right technology choices and future-proofing your choices is think ahead. Try to make decisions early on, because there is nothing worse than getting 10, 15 steps in and capping out. And staring across at the mountain you should have been on thinking, I've either got to be content with staying here, or I've got to climb all the way down again. And climbing all the way back down means probably tearing out some pretty embedded technology at this point and upgrading to a more capable version. So getting on the right mountain means having that long-term view, and it also means avoiding the temptation of, in the early stages, yeah, that's cheap, but it'll do. Which gets me to this issue, which is that step one, there's a lot of stuff that you won't have in place that you need in place. And I call it kind of the infrastructure tax, which is that sensors, network services, we just talked about, even the software platform itself potentially. The value of that amortizes over the step. Every time you do another step, you create more value out of that investment. It's like the network, right? Let's say you needed one Wi-Fi tool in a plant and you had to buy a Wi-Fi network just for that one tool. Well, the ROI on that Wi-Fi investment will be awful. But it won't be by the time you've done all 200, 300, 2,000 tools, whatever it might be. So there's a danger that the first step, because the first step has to bring in all this foundational stuff, it really has a very poor ROI. Right? So how the heck do you purchase that? It's probably the lowest value step because it's the lowest risk one that you want to start off with, but it may have the highest cost because it bears the full burden of that infrastructure. So if you try to buy in a traditional way, you'll never do step one. So, as I said, think cloud, think infrastructure as a service. It's a very cheap way to get compute infrastructure, right? Because you just pay for what you use. Look for OpEx purchase options. That's really important because if you're going to amortize the value of that foundational investment over many steps, then you better amortize the cost of that over many steps as well. There's too much tendency, and this is really fun, I think, there's too much tendency still to take a very traditional capital purchase approach to ingesting this kind of technology. If you treat networking, for example, as a capital expense and you load up that first step with that cost, there won't be an ROI in the first step. You'll never get it done. So it's not CapEx anymore. I think outside that traditional ROI box as well. You know, when you get into this CapEx mindset, very often when we're in discussion with procurement departments, what they're saying is, yeah, you know, our CapEx cutoff is it's 12 months, or it's 24 months, or it's 8 months, whatever it is. If it doesn't meet a 12-month ROI, it doesn't even get considered. Well, you might not make a 12-month ROI on some of that foundational investment. So thinking outside the ROI box, going beyond the traditional CapEx approach, looking for OpEx purchase options, looking at the notion of infrastructure as a service, these are all ways to amortize the cost over many steps and unburden the first step so you can get started. So kind of getting to the close here, just to sum up, kind of the flip side of the best practice and everything I've told you in this is things we've learned by watching our customers deploy, and we've tried to help people with that best practice as well. But here are some popular ways to fail, actually. The first one is relying on technology to solve problems and transform your business. Technology doesn't change your business. Changing the way you do things changes your business, and technology gives you to change the way you do things, right? So one great way we've seen people fail is thinking that merely the adoption of digital technologies will create positive outcomes. And with the best will in the world, you can provide all the visibility and insight that in the world, but if people don't act on it and do something different as a result, nothing will change in the business. So you do see people fail at step 1 or 2 because they're really not leveraging the opportunity to do things in a different way, right? So technology itself isn't going to change a thing, but it will give you ways to do things in a new way, which can be transformative. Another good way to fail is to buy 10 different solutions and then 10 different problems. Taking that stepwise approach, there's it's not a tendency or a temptation, but maybe an old habit to slip in, which is looking for a new solution at each step. That's not what I'm advocating at all. I'm advocating choosing technologies, choosing platforms that allow you to grow into those steps in a coherent way with the same set of tools, that each step is part of a whole. They all add to each other. Each time you take a step, you create more and more value for the steps before. Right? If you just buy 10 different solutions to solve 10 different problems, you probably get a little bit better, but you certainly won't be transforming the business. I've kind of harped on this a little bit, but getting wrapped around the 10-year plan axle and just never getting started, that happens too. We've seen people get too tangled up in detailed requirements definition of some magical future state that it just seems either too overwhelming to tackle, or you just never get finished in that definition exercise, and so you never get started. Leaving IT out of the loop, brilliant way to fail. IT is going to be in the loop, and right at the front as well, and bringing IT into these operational problems and these operational solutions is critical. The earlier they're brought in, the better. Leaving IT out of the loop is definitely a recipe for going off the rails. And then, as I said, making dead-end technology choices, making technology choices that run out of steam after just a few steps. And in particular, and I can't say this enough, step 1 in some ways is the hardest step. Well, in every way, it's the hardest step. And it has the lowest value. It's the first time you do something. You've got to do all that coalition building internally. You've got to break down those barriers. You've got to learn new ways of ingesting technology. You've got to maybe fund fundamental infrastructure that doesn't exist. And there's a huge temptation to try to make that step as cheap as you possibly can. And a great way to make digital transformation cheap is to buy fairly limited capability technology. And that temptation will be strong. And it's just a terrible thing to succumb to, because you'll get 2 or 3 steps down the road and you'll realize that you made the wrong choice. So that's pretty key. So that's it. I hope that's useful. What I tried to give you there is just our gleanings from, what is it now, 12 years of doing this, what we've seen as people succeed at and fail at. Make a modest start, take a cautious incremental approach, create a transformation roadmap that creates returns at every step, start with the right technologies that take you down the road, and now's the time to, if you haven't done it already, think about that OT-IT integration, both in terms of the way you make decisions and the way you ingest technologies. So that's it for me. Thanks.